Hi, everyone. So we're talking about how to pass data into functions, and we've talked about how to pass primitive types into functions, and the fact that the default for passing primitive types into functions, like ints and booleans and characters, is call by value, which means that a copy is made when we pass it into the function, and then when we're inside the function, we edit the copy. And we talked about the fact that we can override that by actually passing in the address of the variable. Instead of passing in the variable itself, we pass in the address in memory of the variable. And we then have a variable or a parameter that holds the address or a pointer, okay? That's call by pointer. We then talked about passing arrays into functions and how arrays actually work. And the fact that when we talk about an array variable, what we're really talking about is a variable that holds the address of the first value of the array. So this right here holds the address of the first value of a sequential set of whatever in memory. That's what an array is. It's a sequential set of data in memory, all of the same type, okay? So when we actually send an array into a function, what we're actually sending in is the address of the first value of the array. So in essence, just automatically by default, when we send an array into a function, we're using call by pointer. And then inside the function, we use the array just like regular because every array is always the address of the first value of the array. So we use it just like normal. So now we're going to talk about how do we pass classes, objects made from classes into an array. Okay, so let's look at this. Here I made a lovely, beautiful, of course, zoo class, zoo creature class. It's just a basic class. I made everything public just to be easy. We've got a first name, a last name, and two constructors here. Okay, here I have a main function, and inside the main function, I create an object of type zoo creature. My object is wombat. Okay, I then assign the field first name to be Wendy. I assign the field last name to be wombat. Okay, so far so good. And then I call the function change name with my zoo creature. So we go down here, here's zoo creature, here's the variable, and inside the variable, we change the first name to be Willabella. Then we come out here and we print out the wombat's first name. What do you think gets printed out? Which do you think it is? Do you think it's call by value or call by pointer is the default for objects? Let's find out. Okay, so here I've got the code. You'll have to trust me. Here's my zoo creature header file. And here is my main function where I create an object of type zoo creature. I set the first name to be Wendy. I set the last name to be wombat, and I print out first name, last name. I then call the function change name with my zoo creature. X now holds that zoo creature. We change X's first name to be Willabella, and then we print out X's first name, X's last name. We return from the function, and we print out wombat's first name and wombat's last name. So what do we think happens here? Let's find out. Look at that. Up here, before we call the function, Wendy the wombat. Just what you'd expect, exactly what you'd think. We go into the function change name. Inside the function change name, we print out x.f name and x.last name. Willabella the wombat. Again, exactly what you'd expect. Then we return from the function. We print out the first name and the last name. Back to Wendy the wombat. So what that means is that inside our function here, we are actually dealing with a copy. So we're doing call by value again. So the default for objects is call by value, okay? So default for objects is call by value. In other words, within the function, a local copy is made, okay? And so when we change a field of an object in a function, it doesn't remain changed outside of the function because it was made to the copy of the object, not the actual object itself. Okay, so a lot of times when we're calling a function, if we're sending in an object, a lot of times we actually want to modify the object. So how do we do it? We do it just like we did with primitive types. We send in the address, okay? So how do we get the address of an object? We put the ampersand in front of it, that and thing in front of it, right? So we put that and thing in front of it and we say and wombat. Then if we do that, that means that our parameter has to hold an address. So we put that little star there. And that little star means that X actually holds the address. Now here's where it gets a little bit different than anything we've seen before. If I now want to access any of X's fields, any of my object's fields or methods, X no longer has the field F name. X doesn't have the field X name. What X points to has the field F name. So I have to go to X before I can find the field F name. And how we signify that is with this little thing here, dash, I don't know what that is, greater than or less than, whatever that is, dash arrow. There we go. Okay. That equals, that is our way of saying, go to the address inside of X and then find the field. Okay. So let's put this all together. Call by pointer with objects. Here we go. Okay, in my main, here we've got Wendy, or the wombat is a zoo creature. We gave it a first name and a last name. When I send it into my function, I'm sending it in with the address of the wombat. Okay, so the wombat's first name. Oh, sorry about that. So I'm sending in the address of the wombat, which means that here, my function has to hold an address, and that's what that star does right there. Okay. And then in here, I say X pointed at first name equals Willabella. When I come back out here now, and I print out the wombat's first name, I will print out Willabella. So there we go. So when we actually have a pointer to an object, you use what I've always referred to as a pointer dot, which is the dash greater than sign, I think. And that the arrow here. And that basically indicates that we go to the address in here and find this field here. Okay, so in summary, with objects, the default is called by value. That means a local copy of your object is made. That means any changes you make to that object don't remain outside of the function. When you leave the function, the copy gets wiped away from memory. It's gone, it's history. And so any changes you made went away with the copy, okay? If we want to combat that, if we want to do something about that, what we can do is we can use call by pointer with objects. So we're going to use call by pointer, meaning we'll send in the address of the object. We send in the address of the object using the ampersand, the and sign, just like we always did, okay? And then we need to have a parameter that actually holds the address. So we're going to need to put a little star there. And then whenever we're accessing any of our fields, we're going to use this dot pointer here, which is a dash arrow, okay? And that's how we'll access any of the fields and any of the methods. If we have a pointer to an object, we have to use the dot pointer, okay, the arrow here, okay? This way, when we're done, changes made to the object will remain changed outside of the function. So we will be using this a lot. This will be used again and again and again because we use a lot of objects in data structures and we pass a lot of objects into methods, pass a lot of objects into functions. We create objects, it's a whole long story, but we use addresses of objects a lot in data structures. So there you go.